This is for mathematical methods. It comes out of the 2019 VCAA paper, exam 2, question number 19 in multiple choice. I know that the tan of alpha equals d, where d is positive and alpha goes from 0 to pi on 2. And the tan of alpha comes from the graph of y equals the tan of x, which will have an asymptote at pi on 2, and an asymptote at x equals minus pi on 2, and the curve is going to look like this, and I would be expecting that that would be alpha and that there would be d for the tan of alpha to equal d. Okay, so now I'm looking at the tan of 2x equals d, and this is my domain. So if I wanted to consider tan of 2x, then it's going to have a period of pi divided by 2, therefore it's going to have an asymptote at x equals pi on 4, and x equals minus pi on 4, and my curve is going to look like this, and at this height of d, that point there is going to be alpha on 2, because if you replace x with 2x, it's dilating by a factor of a half, so I would have to put alpha on 2 to get d, because the tan of 2 times alpha on 2, the 2's would cancel, the tan of alpha equals d. Okay, so I'm going to change my domain out to 5 pi on 4. So that's pi on 4, that's 2 pi on 4, that's 3 pi on 4, that's 4 pi on 4, that's x equals 5 pi on 4, and I'm going to have 2 more cycles, which means I'm going to have 3 solutions when tan of 2x equals d, and they're going to be at, now the period of this is pi on 2, so this is alpha on 2 plus pi on 2, and alpha on 2 plus 2 pi on 2. So my 3 solutions are alpha on 2, and alpha on 2 plus pi on 2, plus alpha on 2 plus 2 pi on 2. And throwing them all together, it gives me 3 alpha on 2 plus 3 pi on 2, which is 3 outside of alpha plus pi all on 2, and that gives me E as being my option.